Hi everyone, welcome to Math 171 and done. Today our focus is on polynomial modeling, but before we get into it, let's go over some basics on polynomials. A polynomial is an equation or expression with one or more terms. The term must be a constant, a variable, or an exponent. Polynomial modeling is the use of polynomials to solve real-world problems. The formulas represent that of a polynomial, which is a continuous curve on a graph. Here is our example problem.
So our example for today is going to be a farmer has 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river. He does not need a fence along the river. What are the dimensions of the field of the largest area that he can be fenced?
Remember, a variable is a letter that represents a quantity.
So step one is identifying the variables. So the amount of fencing is 2,400. This is going to be our base. The three sides of the fence will be represented as W. The river will be the one part of the fence that is not actually fenced. So for our perimeter, our amount is going to total up to be 2,400 as for that. And W is going to be our sides. We're using W because S looks too much like a 5 and I didn't want the confusion. Alright, so step 2 is going to be creating a visual aid. So we're going to make a small fence on 3 sides and a river going under it. The sides of the fence will all be represented by W. And the area is what we're trying to find on the inside of the fence. We will have to create formulas to have A equal W, which is the length, times 2,400 minus the 2 W's here. That'll be our area formula. So step 3 is creating formulas. So we're going to be using 2 formulas. Perimeter, find out the dimensions of each side, which is going to be represented by W, the longest side, plus 2W, the 2 shorter sides. And then our other formula will be our area formula from earlier, which is A equals W plus 2,400 minus 2W. And perimeter will also be 2,400 equals W plus 2W. So step 4 is find the vertex to figure out the length of the short sides. So A is going to equal, we're going to multiply W by these and get negative 2W squared plus 2,400 W. Now to find the vertex, we're going to have to pull out the 2, negative 2, and we're going to get W squared minus 1,200. Then to find the vertex, we're going to have to split this to get the other end, the maximum area, which will appear over here. So we're going to get A equals negative 2 times W squared minus 1,200. So we split the 1,200 in half and get 600 squared plus 2 times 600 squared. The reason why we did that is because you always have to keep it equal, and so we need to add 600 to this side if we're going to add 600 to this side as well. So this is going to equal out to A equals negative 2 W minus 600 squared plus 720,000. Now the 600 will be the length of our sides, because that is where the vertex happens, and 720 will be the maximum area. Alright. So step 5 is plugging the results of the vertex to find the last side. So from a vertex, we know that W equals 600. So perimeter, which is L plus 2W, will be 2,400 equals L, which is our length, plus our short size, which is 2 times 600. So 2,400 equals L plus 1,200. So if we subtract 1,200 from both sides, we get L equal to 1,200 feet. Okay, so step 6 is displaying the full solution. So the maximum area we can get is 720,000. We multiply both sides, which this is the maximum vertex for the shorter sides, and this is the amount we got from our perimeter. We get 720,000 feet. This was also displayed when we had our other formula, where A was equal to -2 times W minus 600 plus 720,000. This right here was also the same as that right here, which tells us that when we do this problem like this, we can get the solution without even having to go into the area itself. The dimensions are 1,200 feet by 600 feet. That was represented by our perimeter formula we did earlier, where you just plugged in both sides and got the perimeter, which equaled out to 2,400.